Hi everyone, today I'm going to explain the idea of integration by parts. So the integration by parts is a technique we use when we want to integrate a product of two functions. Sometimes normal substitution doesn't work well, so this method helps us break the integral into something easier. So where does the formula comes from? We start with the product rule from differentiation, which we learned from last chapter. Then we would integrate both sides, which would give us uv equals integral u dv plus integral v du. And then we would isolate integral u dv to get the final formula for integration by parts. Here, one function will represent u and the other one will represent dv. And a common question is, how do we choose u? We use the acronym LIPID. L is for log, I is for inverse trig function, P is for polynomial like x squared, and E will be exponential, and T is for trig functions. Usually the function highest on the list becomes u because it gets simpler when differentiated. And this is one example question I have. Here, 2w plus 4 is polynomial, so it's P in the LIPID, so it will be u, and du would be 2dw, dv will be cosine 2w dw, and v will be 1/2 sine 2w. If we use the integration by parts formula here, we will substitute each u, du, v, and dv, and this will allow us to do the following calculation and get the correct answer. And my another example question is integral of e to the power of x times cosine x. Here, using the LIPID, we would know that u would be e to the power of x since cosine x is just a normal trig function. And this is a classic problem because if we apply integration by parts once, we get a new integral that also needs integration by parts again. So like this, after doing the process twice, we eventually get back to the original integral. Then we would collect like terms, and this example shows how integration by parts can loop back but still give us the answer.